So this is the continuation of the previous video. In this video you're going to learn the access bits 4, 5, 6 and 7. So when you set the sector trailer to access bit 4, these are the things that happens. The key A is writable, but after authentication with key B. The access bits are not writable, so the configuration is frozen. The key B is writable as well, but after authentication with the key B. Now here the key B is used for authentication. Some of the uses of this configuration is the key B is the primary key here, and this is commonly used with the value block. Key B acts as a master key, and you can use this to change other key. And key A can be used as a card specific key for accessing data. If you compare this access bit 4 with access bit 3, the only difference here is the access bit in 3 is writable but not in 4. So I'm going to show you how to use the access bits 4. This is the same code I've been using in all my previous videos. If I hit read entire tag, before that you would activate read entire tag. Now as I mentioned before, when you hit this read entire tag, the software uses the default key A, which is set to all FFs. So as you can see here, so the sector 0, 1 and 2, they are not readable because they don't have this the key as FFs. They could be something different. So I'm going to play with the sector block. In fact, the 4 is not available as well here. So I'm going to use this time the sector 5. So this is already in the factor setting. So the way we know it is factor setting is the sector trailer has got access bit 1 and all the data blocks has got the access bit 0. So first I'm going to authenticate sector 5, choose 5, so authenticate, it's successful. Probably you can read the entire sector, so the read is successful as well. Now if you go back, if you remember this the access sector access bits 4, so you can change, but here the primary key is the key B. So the very first thing you do is change the value of key B and as well as the value of key A. So I'm going to key in a default values here. So I'm going to say A1, A0, A1. So I have changed the values of key and key B. I'm going to right click on the sector and change the sector trailer access rights to 4 and say OK. And I'm going to write this entire block of 16 bytes by hitting this W. Now the write is successful. Now if you look at the grid here, it says the access right set to 4. So I'm going to reactivate so I'm going to go with the sector number 5 and I'm going to populate the keys here. So I have got the values of key A and key B. I can authenticate using key A, you can still do it, and I can also read it. Now if you look at the data you received from the card, we know that the value of key A can never be read, so it'll always get zeros. It's the software that populates the value of the key on the grid. Because key B is used for authentication, so it's if you compare this with the access rights 1 where key B was readable. Now if the key B were readable, you will see the values of the key B, and I mentioned before, if the key B is readable, you can use that 6 bytes to store any user data. So here, because key B is it behaves as a proper authentication key, you cannot read the value of the key. Now you cannot do anything to the sector block if you authenticate with A, because if you look at the A, the settings for to write, I have to authenticate with B. To read, I can do A and B. The reason why you're seeing the access bits B6, B7, B8, B9 is it is readable with the A or B, and if I want to change the value of B, so I cannot change the value of the key A and key B, and we know that you cannot change the access rates at all, because in the access bit 4 this is readable. Now let me try to change this thing. I'll say set to 0 0, and I'm going to change this as 0 1. If I try to write, now the write block, in fact this is an error you got from the card. Now if you were working with a embedded system, and if there's any error like this from the card, you will have to reactivate the card. However, because we are using the ACR122U reader writer, it has this auto pooling mechanism enabled. Every time there's an error from the card, it auto pulls, and again it keeps the card active. So I'm going to activate, and so we know that you can't change when authenticate with just key A. This time I'm going to use authenticate with the B, but I'm going to choose the sector number 5. So read is still readable, and you can see here, even though we are authenticating with key B, you just cannot read the value of key B. But however, the software auto populates the grid with the values of the key you entered here. Now let's try to change this time with the, now you have to be careful here. So assume that I want to change the value of key B. Now if I change this, say for example the first byte as 0 0. Now this is something these things can go a bit trickier. So because if you look at this configuration 4, after you authenticate with the key B, key A becomes writable. So if I try to write this entire sector block, so even the key A will get overridden by 0 0. So there is no way you can modify only certain bytes of the sector trailer. It's not possible with the Mifare classic tags. Now I'm going to change the value of key B with 0 0, and remember that we have the value of key A was 0 0 0. So I'm going to write. Now return. Now I'm going to re-authenticate. So reactivate. So go to 5. If you try to activate with the old key, we know that we should get the error message because the key has been modified. So this B2, say B3, B4 and B5. So authenticate. So authentication failed. Now authenticate with this. Now this is successful. So this proves that we have modified the key B. How about if I try to authenticate with if you're not aware of these things, you lose the value of key A. So we knew that the original keys of key A was A0 to A5. If you try to authenticate, you will get error message because during the key change operation we just overwritten all the bytes to zeros. If I authenticate, look at that. So because we overwritten the value of key A with zeros, now you are able to authenticate now. So I'm going to change the values of key A and key B this time, both. You just have to keep in mind that you are aware of these type of things. When this entire sector block is writable, so if you want to change any of this key, you have to know the value of both the keys, otherwise you will end up losing the key. So I'm going to put the keys back to the A0s. So this time I'm also going to try to modify the access bits as well, and in fact we know you cannot modify the access bits. So I'm going to modify the access byte B9 because this is the one byte which is not part of the access bits. So I'm going to set this to 90 and say write. So I have modified that. So let me authenticate with the B0 and authenticate is fine. If you try to read the data, you can see that the B9 got back its original value 00. I think that's all about access byte or access bit 4 for sector trailer. Next I'm going to speak about the access bits 5 and 6. So this is the sector trailer access bit set to 5. Here the key A is not writable. The access bits are writable, but after authentication with key B, and the key B is not writable. If you compare this with the access bit 4, this is exactly the reverse of access bit 4. So in access bit 4 we had key A writable, key B writable, but not the access bits. So one good thing about this configuration is we can change the access bits at a later time. So that's what I'm going to show you next. So I'm going to reactivate the same tag. So this time I'm going to use the sector 6. So authenticate sector 6 with the key A, and I'm going to change the value of key A and change the value of the access rights to 5 and write. So the write is successful. I'm going to reactivate. So activate and read the entire sector. Oh sorry, I have to change the sector to 6. Activate, read the entire sector, and if you look at what's coming from the card, neither the key A nor the key B is readable. So the only thing you can do in this configuration is changing the access rights. So I would like to set this sector trailer back to the factory setting. Now when you use this software, so I just noticed there's something wrong. When you right click here, make sure you have selected this sector. You should see this in a blue background. Then right click, you can see this sector access menu. Set to 1, and I'm going to write. So the write is successful. If I try to read, so you can't, probably you have to authenticate again. So probably I can use this. So if you remember, the key A was set to A0, A1, A3, A4. I should have set this to FFs as well to make it as a factory setting. So authenticate, read. So because we changed the access rights, we are able to read what was in the key B. So this is how this the access bits 5 and changing back to 1 works. So you just have to be take a note of this thing. So if somebody changes or if you have a configuration like that, and if you change back to 1, so then the value of key B will be readable. The next one is when the access bits are 6 and 7. So both 6 and 7 have the identical functionalities. I'm not sure why they're identical. So what what you can do here is key A is not changeable, access bits not changeable, key B is not changeable. So this looks like a very personalized card, and the configuration is frozen, and this is something like kind of a use and throw type of cards. So where even if somebody loses the card, you know, just to replace the new card, so you cannot change the keys nor the access rights. So it looks like, you know, this type of configuration looks very safer, so in the final product. So I'm going to show you now what you can do with this. So I'm going to read the entire card, but going to use probably now, not sure why. Okay, just going to activate and read. So I'll be using the next sector 7, which is in the factor setting. So I'm going to keep in all these things the same. So probably now, because you can't change the value of the keys, you will eventually end up changing these keys before you apply the configuration 6 or 7. So let me make sure the configuration 6 and 7 are identical. So if you look at here, you can't read and write. You can only read, and you can't read and write. Now if you see this configuration, the access bits are always readable. So A3, A4, A5, and probably I can change this as well. So 00, B0, B1, B2, B3, B4, B5. I'm going to change the access rights to either way, it doesn't matter. I can set to 7 or 5, both are the same. Sorry, 6 or 7. Now I'm going to write. So there is an error. Oh, sorry. What has happened was, I did not. When you hit this read entire tag, the current authentication will be the last sector. So I have to authenticate sector 7, authenticate, and I'm going to write. So the write is successful. So first I'm going to authenticate with the key A and read the sector. And if you look at what's coming out of the card, both the key A and key B values cannot be read. However, you can read the value of the access bits. Now I can also authenticate with the key B and read again. It's the same thing. If you try to modify something, say I'm going to modify 01 and this set to 00, try to or change the access rights to something different. So I try to set to factory setting and hit a write, you will get error message. So probably now, as I mentioned before, if you're working with embedded system, you have to go through the reactivating the card. So I think we covered more or less everything, all the access bits of the sector trailer. In my next videos, I'll be discussing about some of the access bits which has been missed out. Thank you.